Hello students, in this video I'll explain you how to find solution of the given system of equation by using Gauss Jordan method. So for the given system of equations, to solve it by Gauss Jordan method, first let us write its augmented matrix. Augmented matrix of the given system of equation, it is coefficients of x, y, z 1, 1, 1 and 10. Second equation 2, minus 1, 3 and 19. From third equation it is 1, 2, 3 and 22. This is the augmented matrix of the given system of equation. Now first we have to observe first row first element, do we have non-zero element? And yes, here it is non-zero element and it is already we have it as a 1. Using that element, which is called as leading element of the first non-zero row, we have to make element below that to 0 in the column. For that operations we are writing R2 changing as R2 minus 2R1, so that 2 minus 2 it becomes 0. R3 also we have to change R3 minus R1. Using this only you have to make this and this to be 0. Okay, the resulting matrix is equivalent to first row no change, we are keeping the first row as it is. Second row we are changing 2 minus 2 0 minus 1 minus 2 it is minus 3, 3 minus 2 it is equal to 1, 19 minus 20 it is minus 1. Third row is we are changing as R3 minus R1. 1 minus 1 it is 0, 2 minus 1 it is 1, 3 minus 1 it is 2 and 22 minus 10 it is equal to 12. This is the resulting matrix. After this, now by using this element, which is leading element of the second non-zero row, which is the first non-zero element, we have to make element above and below as 0. So if we make this to be 1, then it will become easy for writing the operation and also operating. Therefore, if there is a possibility, we'll make that as a 1. Here it is easy to make this as 1 by just interchanging second and third row. We are interchanging. So that by doing, we get first row no change. We are keeping the first row as it is. Second row, third row as second row. It is here, and second row as third row 0, minus 3, 1 and minus 1. So doing this, it becomes easy now for us to make element above this and below this to 0. For that operation I have to change the first row, R1 changing as R1 minus R2. Using this only you have to make this to be 0. Similarly, simultaneously we are making the third row also element this as 0, that is R3 plus 3 times R2. Multiply 3 to this, adding with this becomes 0. So that the resulting matrix is equivalent to first row we are changing as R1 minus R2, that is 1 minus 0, it is equal to 1 only. 1 minus 1 it is 0, 1 minus 2 it is minus 1. Next 10 minus 12, that is minus 2. That is the resulting matrix, I mean the first row elements. Second row we are not changing, keeping the second row as it is. Third row we are changing as R3 plus 3R2. 0 plus 0 it is 0. Minus 3 plus 3 it is 0, because this is the operation we are using. Next 1 plus 2 times 3 times the 2 it is 6. 1 plus 6 it is 7. 1 plus 6 it is 7. Next minus 1 plus 12 threes are 36. Minus 1 plus 36 it is 35. So 35 you get here. Now this is the leading element of the third non-zero row. This element, if we make it as 1, then it becomes easy for us to make the elements above this to 0 in the column. For that operation I use R3 as 1 by 7 times the R3. So that resulting matrix we get 1, 0, -1 and -2. Second row 0, 1, 2 and 12. No change in this first and second row. Third row only we are changing 0, 0 and 1. And this is 5. 35 by 7 is 5. This is the leading element. We have made that as 1. Now it becomes easy for us to make elements above this to 0 in the column. That means I have to change first row elements, that is R1 plus R3. So that -1 plus 1 it becomes 0. R2 also changing as R2 minus 2 times R3. Multiply 2 to this, subtract with this, so that this becomes 0. So the resulting matrix is now equivalent to what? First row we are changing R1 plus R3. 1 plus 0 it is 1. 0 plus 0 it is 0. -1 plus 1 it is 0. Next, -2 plus 5 it is equal to 3. Next, second row also we are changing as R2 minus 2R3. 0 plus 0 it is 0. 1 plus 0 it is 1. 2 minus 2 it is 0. 2 minus 2 it is 0. 12 minus 10 it is 12 minus 10, that is equal to 2. This is 2. And last row no change. We are keeping the third row as it is. Now this augmented matrix has been reduced to diagonal matrix. So by now with this we can write x is equal to 3 from first row, and from second row you get y is equal to 2, and from last row we get z is equal to 5. This is the answer to this question.